Integration of rational functions. If the integrand is of the form p of x by q of x, if the q of x is non-zero for any x, then integral p of x by q of x into dx can be solved by using any of the following method. So this is the integration of rational functions. So the integration of rational function can be solved by using any of these two methods. One is partial fraction method, another one is perfect square method. So partial fraction method can be applied for the partial fraction method. The method of partial fraction is preferable only when q of x is factorable into linear or quadratic factors that cannot be further reduced. If the denominator q of x is factorable, then we can apply partial fraction method. If not, then we go for perfect square method. So this method can be applied when q of x is quadratic equation. The following formula can be used to convert into perfect square. There are two formulas, x square plus ax to convert into perfect square formula, x plus a by 2 the whole square. What is x plus a by 2? The coefficient of x is a divided by 2. So x plus a by 2 the whole square minus the inner term take square and outside, right in the outside. The second formula is minus x square minus ax is equal to x minus a by 2 the whole square minus a square by 4. So by using any of the formula, we can convert into perfect square. Then we can solve the integral. The first problem, evaluate the integral dx by x square minus 3x plus 2. So this is the integration of rational function, because the integrand is 1 by x square minus 3x plus 2. This is of the form p of x by q of x. P of x is 1, q of x is x square minus 3x plus 2. Okay, to evaluate the integral of rational function, we have two methods. One method is partial fraction method, the other method is perfect square method. But partial fraction method can be applied only if the denominator is factorable. But you see, this quadratic equation can be factorable. This quadratic equation can be written as x minus 1 into x minus 2. So the q of x is factorable, then we can apply partial fraction method. So here I am going to apply partial fraction method. Okay, take the given integrand function. The integrand function is 1 by x square minus 3x plus 2, which is equal to 1 by x minus 1 into x minus 2. Okay, now I am going to apply partial fraction. 1 by x minus 1 into x minus 2, which is equal to a by x minus 1 plus b by x minus 2. Okay, now take LCM. 1 by x minus 1 into x minus 2. Here a into x minus 2, take multiply, plus b into x minus 1 whole divided by x minus 1 into x minus 2. So cancel this. So we are getting 1 is equal to a into x minus 1 plus b into x minus 1. A into x minus 2 plus b into x minus 1. Okay, by partial fraction method, I want to eliminate either a or b by putting x value. So here put x is equal to 2. When you put x equal to 2 here, 1 is equal to 0. Put x equal to 2, 2 minus 1, 1. So which implies that b is equal to 1. Okay. Next put x is equal to 1 to eliminate b. So here 1 is equal to 1 minus 2 is minus 1 plus 0, so which implies that a is equal to minus 1. So we found a and b value. Substituting these two a and b value here. Substituting in 1. So 1 implies that 1 by x square minus 3x plus 2 is equal to, both are equivalent terms, so a value is minus 1, so minus 1 by x minus 1, and b value is 1, so 1 by x minus 2. So now the integrand function is factorized into two terms by partial fraction method. Okay, now I am going to integrate. Now the given integral dx by x square minus 3x plus 2 is equal to, already we found the partial fraction, the term is equivalent to this. Therefore this term can be written as integral minus 1 by x minus 1 plus 1 by x minus 2 into dx. This term 1 by x square minus 3x plus 2 can be written as minus 1 by x minus 1 plus 1 by x minus 2 into dx. Now this can be written as into two integral parts. So minus integral dx by x minus 1 plus integral dx by x minus 2. Now integration of dx by x minus 1, log. So log x minus 1 plus integration of dx by x minus 2, log x minus 2. Now you can write the integral integral constant is c. We know the formula log m minus log n, log m by n. So this is the answer is log of x minus 2 log m by log n plus integral constant c. So this is the answer of the problem. Second problem, evaluate the integral dx by x square plus 2x plus 3. Okay, so the integral function is 1 by x square plus 2x plus 3. You see, this is also a rational function, p of x by q of x. P of x is 1, q of x is x square plus 2x plus 3. But the denominator q of x cannot be factorized. You see, we cannot factorize this equation. 3 cannot write 1 into 3, we cannot write from 2. So this is not factorable. So the denominator q is not factorable, then we cannot apply partial fraction method. So I am going to apply the second method, perfect square method. Already you know the formula for perfect square. The perfect square formula, x square plus ax is equal to x plus a by 2 the whole square minus a square by 4. So by using this formula, I am going to convert this quadratic equation to perfect square. Okay, so what is that? The denominator equation, x square plus 2x plus 3 is equal to, use the formula x square plus ax. What is a here? 2. So x plus a by 2, 2 by 2 is 1. So x plus 1 the whole square. Listen carefully, x plus a by 2. What is a here? 2. 2 by 2 is 1 the whole square minus, take the square of the inner term. A square is 1, a square by 4. So taking square of the inner value square is 1. So this is the quadratic equation is converted into perfect square. Now this term I am going to use in the integral. Okay, so what is the given integral? Integral dx by x square plus 2x plus 3 is equal to integral dx by the term, the q of x is converted into perfect square method form. So x plus 1 the whole square minus 1. Okay, so now already, but you see one mistake here. This is only for x square plus ax. What the next term is 3. So here you have to write 3. So 3 minus 1 is 2. Actually this is x plus 1 the whole square plus 2. So that here plus 2. Okay. So now the integral term can be written as x plus 1 the whole square plus the 2 can be written as root 2 the whole square. Root 2 the whole square. Now what is the integral formula? Integral formula is integral dx by x square plus a square. This is 1 by a tan inverse of x by a. So this is the formula. So by using this formula here, this is x square plus a square. So apply this formula. 1 by a tan inverse of x by a. So integral over plus integral constant. This is the answer of the problem.